Pull! Oh! Yeah!
Let me tell you something you already know. Life isn't all about rainbows and sunshines. It's a very mean and nasty place. And I don't care how tough you are, it will beat you to your knees and keep you there permanently if you let it. You, me, or nobody is gonna hit as hard as life. But it's not about how hard you hit, it's about how hard you can get hit and keep moving forward. How much can you take and keep moving forward? And that's how winning is done. Good day, everyone. I'm from Group 5, and today we are going to learn about acids and bases, specifically its properties of water. So, what are we waiting for? Let's dive right into it. Oh, wait. First things first, we need to learn what acids and bases are. Acids have a sour taste, such as vinegar. Acids react with carbonates and bicarbonates to produce carbon dioxide gas. It also reacts with certain metals to produce hydrogen gas. Acids react with bases to produce salt and water. It also reacts with certain dyes. While for the bases have a bitter taste. It reacts with certain dyes, and it also reacts with acids to produce salt and water. And lastly, bases feel slippery, and that is the reason why soaps are slippery because it contains bases.
In addition, acids and bases dissolve in water, and because they increase the concentration of either protons or hydroxide ions, they suppress water self-ionization. Moreover, acid is a substance that donates a proton, while a base is a substance that accepts protons. Also, with a base, water acts like an acid, while with an acid, water acts like a base. Lastly, do you know water also has properties of acids and bases, and this allows it to be a universal solvent and dissolve many different molecules?
Water is amphoteric. It is capable of acting as either an acid or base. Say for example this equation. H2CO3 reacts with H2O to form HCO3 and H3O. In this equation, water acts as base since the product H3O gains hydrogen ions. In the second equation, NH3 reacts with H2O to form NH4 and OH. In the second equation, water acts as acid since the product OH loses hydrogen ions. Let's proceed. Ionization is any process that leads to the dissociation of a neutral atom or molecule into charged particles. Autoionization in water is when you have two water molecules that are doing acid-base reaction with no other molecules present. The illustration below shows the reaction in which water molecule donates one of its protons to a neighboring water molecule, either in pure water or in aqueous solution. Hydronium is the common name for the aqueous cation H3O, while hydroxide is a diatomic anion with chemical formula OH.
In chemistry, a reaction that is at equilibrium is represented as K, whereas Kw is created to show the equilibrium condition for the self-ionization of water. Kw is equal to H3O plus times OH minus is equal to 1 times 10 to the power of negative 14, which means it is an ion product of H2O. Because the equilibrium constant only refers to water, we can write the ion product constant. This occurs at 25 degrees Celsius. H plus times OH minus is equal to 1.0 times 10 to the power of negative 7 times 1.0 times 10 to the power of negative 7 is equal to 1.0 times 10 to the power of negative 14.
The Kw increases as we increase the temperature, or if there's an increase in the temperature. The relationship between the two is directly related, and the reaction is endothermic. When we say endothermic, these are chemical reactions that use or absorb energy from its surrounding to form a product. We can use melting the ice as an example because the ice absorbs the heat, causing it to melt, and then it will become a liquid, which is the product. This reaction lowers the temperature of their surrounding, thereby creating a cooling effect. Because Kw is larger at a higher temperature, the auto-ionization of water is more product favored at a higher temperature, thus resulting to more H3O plus formed when the auto-ionization of water is present at a higher temperature. pH scale is a measure of how acidic or basic the water is. The range goes from 0 to 14, with 7 being neutral. pH of less than 7 indicate acidity, whereas a pH of greater than 7 indicates a base.
Things to remember. If H plus is equal to OH minus, it is a neutral solution. If H plus is greater than OH minus, it is an acidic solution because there are more H plus ions than OH minus ions. And lastly, if H plus is less than OH minus, it is a basic solution because there are more OH minus ions than H plus ions. Formula for pH and POH. pH is equal to negative log H plus, or simply H plus, is equal to 10 to the power of negative pH. POH is equal to negative log OH minus, or simply OH minus, is equal to 10 to the power of negative POH. Examples. Calculate OH minus in vinegar with H3O plus is equal to 1.26 times 10 to the power of negative 3 molarity. So for the solution, Kw is equal to H3O plus times OH minus. So you are looking for OH minus. You need to divide both sides H3O plus to get OH minus. So you're going to be left out with OH minus is equal to Kw divided by H3O plus. Kw is equal to 1 times 10 to the power of negative 14 divided by H3O plus, which is 1.26 times 10 to the power of negative 3. If you divide that in your scientific calculator, the answer will be 7.9 times 10 to the power of negative 12 m, or molarity. Is vinegar acidic or basic? We all know the answer for that, but we need a scientific solution. So here it is. H3O plus is equal to 1.26 times 10 to the power of negative 3, while OH minus is equal to 7.9 times 10 to the power of negative 12. If you compare the two numbers, which one is bigger? So yes, it is the H3O plus. So we can say that vinegar is acidic.
These four simple problems, we are doing the Kw calculations. Problem number 1, we are given the OH minus concentration and it asks us to calculate the H3O plus concentration, and we are going to use this relationship Kw equals H3O plus times OH minus, and this is always equals to 1 times 10 to the minus 14. So for the first problem, if we know OH minus and we're trying to calculate H3O plus, we can do some manipulation of the Kw equilibrium expression. And H3O plus is going to be equal to Kw divided by OH minus. Plug in our Kw, 1 times 10 to the minus 14. Plug in OH minus, it's 2.0, and do the calculation. So 5 times 10 to the minus 15. The question number 2 asks us, is this acidic or basic?
So here we want to compare the H3O plus concentration compared it to the OH minus concentration, which one is greater. H3O plus concentration is 5 times 10 to the minus 15, while OH minus concentration is 2. Again, don't let those negative exponents trick you. So minus 15 is tiny, while OH minus concentration is huge, so this solution is basic. The third question is, what is the H3O plus concentration for a solution with a given OH minus? So again, we want to use kW, so we are doing the exact same calculation. H3O plus is equal to kW divided by OH minus. kW is 1 times 10 to the minus 14. OH minus is 6.2 times 10 to the minus 3. So, do the calculation. 1 times 10 to the minus 14 divided by 6.2 times 10 to the minus 3. So the answer is 1.6 times 10 to the minus 12. Question number 4. Is it acidic or basic? So we are going to compare H3O plus to OH minus. H3O plus is 1.6 times 10 to the minus 12. OH minus is 6.2 times 10 to the minus 3. The 10 to the minus 3 is greater than the 10 to the minus 12. So again, the solution is basic.
So for this problem, we are tasked to find out what is the concentration of OH ions in HCl solution whose hydrogen ion concentration is 1.3 molar. So again, Kw equals to H3O plus, or you could also use H plus times OH minus. That is equals to 1.0 times 10 to the power of negative 14. So we are given 1.3 molar for our H plus value, and we are tasked to find the value of the concentration of the OH ions. So the formula for the OH minus is equals to Kw over H plus. That is 1 times 10 to the power of negative 14 over 1.3. And that is equals to 7.7 times 10 to the power of negative 15 molar. Additionally, this means this substance is acidic since our H plus value is much higher than our OH value at 1.3 molar. Next up, let's try to solve for this problem. So, the Kw for water at 0 degrees Celsius is 0.12 times 10 to the power of negative 14. Calculate the pH of a neutral aqueous solution at 0 degrees Celsius. So in water, the concentration of hydronium ions, or H+, will equal the concentration of hydroxide ions. That is H+ equals to OH minus. Then again, Kw equals H+ times OH minus. For this problem, we are not given the value of H+ and OH minus. But it is stated that this aqueous solution is at neutral state, which means the H+ and OH value is equal. So to get their value, we would just have to take the square root of our Kw at 0 degrees Celsius. So in this problem, since temperature is included, normally we would have to look for the Kw in this particular temperature. But since the Kw for 0 degrees Celsius is already conveniently given, we can now proceed to take its square root. So the square root for 0.12 times 10 to the power of negative 14 is 3.46 times 10 to the power of negative 8. Now we can get the pH value. So pH equals negative log H plus. So negative log 3.46 times 10 to the power of negative 8 equals 7.46. So the pH value for this aqueous solution is 7.46.
For overall understanding, acid and bases are important in living things because most enzymes can do their job only at a certain level of acidity. We already know that water is a universal solvent that can dissolve a wide variety of molecules because it possesses both acidic and basic properties. Lastly, if we want to know more about acid-base chemistry, it becomes possible to anticipate and explain the consequences of a wide range of apparently unrelated reactions.